NQA at the moment, virtually doing virtual audit on our DFP program. Right? So I don't foresee any interruption, okay, this morning, because our class will end at 11:30, and I do have a meeting later at 11:30, but I don't think it will overlap. But just in case that there is something, sometimes the NQA assessors, they will need something, they will require lecturers or something like that. I might be called away at a moment's notice. So if that happens, just continue, right? Continue with what we are doing. And of course, I'll come back as soon as I can inform you guys. But for now, I don't foresee any interruptions so far, right? So we'll just foresee it as usual, okay? Okay, if anything, I will inform you guys if there's any call for meeting before or prior to 11:30. Okay, so since if there's no call, we just proceed now, as normal. All right. So this is week 9. Okay, so week 9 we are going to look at the practical for week 9. Right. Let me share my screen. Well, if you're wondering why my voice has an echo, okay, I'm at our campus, right? I'm at our campus inside one of the consultation rooms, so I'm using it because I think we have some privacy and also not to disturb other lecturers, all right? So, but I think it should be clear. You still can hear me clearly. Can I confirm? Can you hear me clearly? Yeah.
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 Okay. All right. So. Okay, so if you open up week 9 practical, you'll find a PDF. Uh, it's called VLSM Workbook Student Edition. Okay, the title. Okay, VLSM Workbook Student Edition version 2. Okay, right. Please download it from the Google Classroom if you haven't done so. Okay, and open it up, yeah, because we'll be using this workbook. I will be explaining a little bit about the workbook. Okay, this workbook, again, as the same as the subnetting workbook, it allows you to have practice and some exercises inside here concerning the variable length subnet mask. It will help you to solidify, your knowledge about VLSM, okay, by doing some of the exercises given. All right, so let's proceed. You guys want me to record this one?
Record?
You want me to record this session on this VSM workbook?
Oh, okay. Record.
Okay lah, record lah.
Okay, I record it. All right, so I only have one monitor because I installed my laptop. So if you have any question, if you message, I might not see it. Maybe just unmute and ask me directly, yeah, using audio. Okay.
Okay.
Okay. So let's go to the workbook. Okay. Again, as usual, you can use a PDF editor to enter directly your answer inside. Okay. Right. So let's move on to, yeah. Okay. So here's some notes first. Okay. About the class rules versus cluster submitting. This is the first thing we learned earlier on about IP version 4 subnetting, right? And explanation about what is VLSM, further explanation. Don't worry, we've already covered all that we need to cover. All right. So let me just present the when we are going to you get disturbed by the other things. Right. So, okay, you can see the workbook, yeah? Can I confirm?
Oh yeah.
Yeah, can.
Okay. All right. So the only thing I want to comment here in this notes is that because we did specifically talk about routing protocol. So when you see what you see here, the protocols here mentioned here, you can see that we have. Let me just load pay attention and just mm, right. So when you see what you see here, all this RIP, OSPF, EIGRP, dual ISNS, and BGP. These are routing protocols. Yeah, it's not part of our syllabus for this course. Okay, but you will learn about it in the intermediate level of networking, computer networks. Okay, you start to learn about more about routing and routers. So for now, just know that these mentioned protocols here are routing protocols. Okay, so it says VLSM is supported. Okay, VLSM is supported by the following protocols. Okay, what does it mean that it supports is that instead of the traditional subnet mask that you see when you are doing normal without VSM, you can see that, and you know the prefix or the subnet, sorry, not prefix. The subnet is not that means you can have a prefix of 24, 25, 26, 27, and then there's sometimes the interface, because if, after you do a VSM, just like subnetting, each network you create will be connected to the router, and the router supports uh, the routing protocols know how to route based on network created using VLSM. That means it's when it sees the subnet mask, because when you do VLSM, yeah, remember that you can have one subnet with slash, the example 25, another subnet with slash 26. Of course, you write out the routing protocol straight off, right? So that means the routing protocols, when they want to route, remember what a router needs to do? Can someone mention it? How does a router know what to do? How to route a packet? What does a router do?
Transfer packet wide area network.
Yeah, they inspect the packet, right? Next, they will look at destination IP address, and then perform ending, right? Ending between IP address and subnet mask, right? Remember this subnet ending, yeah? You guys remember, right? Perform the binary Boolean ending between the binary of IP address and the subnet mask to get what? So you can get network address. This is the process of routing. So when you know that when the router knows the network address, it will then be able to search in its routing table for the correct network address mapped to which interface. Once it finds it, it will forward the packet through that interface, right? So what it says here, routing protocols is you can select which routing protocols you want to router to run. And when the router performs this ending, it will, when it looks at subnet mask, okay, it understands subnet mask created using VLSN. That's what it means, yeah. Okay, VLSN is supported by the following protocols: RIP version 2, these are all the protocols available on the router. Okay, it's supported means then the ending process can recognize subnet mask created using VLSM. So when you are configuring the router interface, okay, because the network connected is created using VLSM, their prefix or subnet mask is variable length. Okay, so the routing protocol supports VLSM. Okay, right. So then we move on to the benefits of VLSM. Okay, allowing efficient use of address space, allows the use of multiple subnet mask lengths. Well, we see that for class C, you can have 25, 26, 27, 28, 29, 30, for example. Okay, it breaks up an address block into smaller custom blocks, and each blocks may not be the same size, yeah? Each block can be different sizes in terms of number of usable hosts supported. Okay, allows for route summarization. Now, this routing summarization, uh, you might be wondering why you don't know about this. Well, because this also is a topic reserved for the intermediate course. Okay, what it simply means that if VLSN is used, then the subnet mask, okay, you can basically summarize your configuration. Okay, I don't want to talk more about this because this is not inside the what are syllabus for this semester, this course. So we'll talk more about routing summarization in the next intermediate network class. Provide more flexibility in network design simply means you can now have variable size subnets. Support theoretical enterprise networks. Basically, it's the same thing. It means you want to divide subnet network, and you can support now with different sizes depending on requirement by the organization. Right, so this workbook explores three different methods to figure out subnets. You can see that subnets means you subnet a subnet, so nested subnetting. Okay, the box method, the circle method, and a VLSM chart. So in the tutorial, we simply do it, okay, based on magic number. Okay, using magic number, I think is very quickly you can create the VSM. So in this workbook, we have three other methods: the box method, circle method, and VSM chart. So the box method is basically using box to indicate the division of the subnet, the subnets also to quickly show intuitively in form of a box diagram. Circle method, another method using diagram technique, but it looks like a pie chart. The ones I used to give example as a cake, cut into smaller pieces. And then a VLSM chart. VLSM chart is provided to you already, so you can straight away use it as a reference. So the VLSM chart as a reference is only useful if it's class C, because going up to class B and class A, the VLSM chart becomes unwieldy. It's not so easy to use when you have hundreds of subnets, because that is allowed for class B and A because it has more bits more bits to borrow. Okay, that means more bits at the network portion and more bits at the host portion. So a VLSM chart may not be so suitable for class A and class B, but class C is doable. Okay, it's small enough so you can look at the chart in its entirety. Okay. Okay, so here, this page, you can see a subnetting example, a classical subnetting example. It says that you have an example here. There's one, two, three, four, five subnets. Okay, five subnets. Each one containing 30 hosts. So it's actually is 30, 25, 2 to 12 required. But traditional subnetting means all subnets have to be equal. So here the example is showing you that if you are using the standard subnetting, you'll be wasting um, at least 28 addresses each here. Okay, because the required is only two address, right? Two interface addresses you need. So if you allocate equally, because of this requirement, 30 hosts, here also has to be 30, right? For wasting addresses there. Okay, so what is the box method? I think I've explained in the subnet earlier on, yeah, in the subnet workbook. What you need to do is basically find out how many bits you need to borrow to support the maximum size, 30. And then you'll find out that in fact you have to borrow 3 bits to get 32 hosts, right? And that means you can create at least 8 subnets. So to support the 2 hosts, you have to look at the host bits. So 20/27 means you borrow, so you have 5 bits at the host. Okay, so 2 power 5 minus 2 gives you the usable host address, 30 usable, 32 hosts including network and broadcast. So this is standard subnetting. You need 5 subnets, so you just pick any 5 subnets you want, a range that you want to use, and you can see that these are the selected, okay? These are the selected subnets. The next you have these are selected, and then you have 3 extra for future use. Okay, the problem is all equal size, so we are wasting space, especially at the wide area network subnets here. Actually, this one just need 2 usable hosts each. That's the required. But because we are using /27, 30 minus 2, means you have 28, right? Right. So that's the problem. Okay. So the box method means you create a diagram to visualize the subnets you create. So originally it's 0, 25. That's the whole range. Okay. Since you wanted a /27 subnet, okay, you have to subnet it by that prefix, right? So that means we will create 8 subnets. As you can see, 8 subnets. Okay, how do you work on this is that first the whole diagram, you have the first address, bus address that becomes a network and broadcast. And then when you divide into 2, okay, you have for the first subnet, um, network address, broadcast address. Then network address, broadcast address. Divide into 2, into 4, right? Then you have network, broadcast, network, additional broadcast. Divide into 8, after 4 is 8, then you have additional, then you can see 0, 31, then it's 32, 63, okay? Right, so if you prefer to use box method, it's fine, okay? If you prefer to use magic number method, it's fine as well, right? And you'll see that later, we'll also see that is also the circle method and just the chart, right? Another example, the classless subnetting example, right? Now, here, the box method is able to show you what happens when you actually do subnetting, right? So you can start that with the subnet is you will arrange, okay, this is a step, you arrange from the biggest to the small. Let's say we call this one A, okay, based on the size of A, because it's not given here, so I will do it myself. C, D, E. So normally you arrange with subnet A required 30 horse, subnet B required 25 horse. You arrange it or you sort it in the largest horse requirement first, going down or descending. D and E is 2 and 2. So once you get this requirement, you know A and B needs /27. But 12, okay, is that means you don't need 5 bits for the horse part for 12. So for 12, what is the number of bits in horse part? So 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16. 16 minus 2 is 14. 14 covered 12. So 4 bits at the host side means you have 4 bits at the network portion. So the use /28 cover this one, right? Then after that, D and E you only is probably is /30. 2 bits at the host side. 2 power 2 is 4, 4 minus 2 is 2, 1 fit. So if you borrow, I mean, if you have 2 bits at the host side, that means at the network portion, you have 6 bits, so 24 plus 6 gives you /30. Yeah? For both this and that. Right? So this is how you do if you're doing box method, you will notice that you have divided into, let's say, for the first one, you want to create /27, right? So /27 means you need to borrow 3 bits, right? 3 bits give you 8, okay? Give you 8. Why is this blank? Why is this blank, this side? Blank? Because it's not used. It's free. It's a free range address between 1 to 8 to 255 is free for further use. But dividing by 8 because we are borrowing 3 bits, yeah, 3 bits, okay, to give us /27. So the first two /27 means this range. Okay, let me just highlight it here. This range, okay, this is this. Okay, and then the next one is the range after 31, which is this. And then you further divide. Okay, now you divide into, because you 4-bit is 16, right? So the next available after 63 is this. So /28 gets this. Right? After that, you divide again into, I think, because 2 power 2 times 2 power 2 until you get 6, okay? 6 times, okay? 2, 4, 6. Then when you divide, you'll find that the size will be this, okay? Between 80. So you see the range, yeah? Take note the range. So the 30, the first range after that for slash 30 is this. Second is this, right? And then you'll finish. You have 5 subnets. So that means all the white color, this, and this, free to be used for further assignment. Okay. Right. Compare this. The white are the free range compared to this. The free range here is only this, and this. Right, for subnetting. For VLSM, the free range is this, and this. You can immediately see how many addresses you have saved because you're doing a more precise subnetting, which is VLSM. Right? Any question, please just let me know. Okay? Right, so visualizing subnets using the box method. As I explained earlier on, /24 is the entire box. /25 is to divide the box into 2. Recall, you write the addresses. The first is network. Okay, here the first is network. Second address here is the broadcast, and then the range is 1, 2, 254. Right? So when the moment you borrow 1 bit, you have 2 subnets. So all you need to do is this here, if I replicate, okay, if I replicate here, you divide into 2, okay, you write the next subnet is 128, so, okay, and then the one before that is 127. So the range is 1 to 1 to 6. So here, this is network address, this is broadcast address, network address. The range is 129 with 254. Okay, so that's the step, right? So you can see that here. The next step, if you want further, this is to visualize /26 divide into 4 because /26 borrow 2, 2 borrow 2 is 4. Okay, and just continue dividing it. Okay, so how it happens there is you divide it like that and proceed to do normally like that, like that. So you basically write on the upper left corner the network address, okay, and you'll find that you get the range very easily as well, right? So again, this is feasible if you're doing class B. When you're doing class B and A, this method is not very feasible to do that. So magic number probably is a better way to do. Right? So then we proceed, /27 looks like that, /28 looks like that, and then /29, finally /30. Okay? So for class C, I think this is a good reference for you to look at. Right? Okay, the next is a problem. Okay, a problem that you and some simple answer. Okay, using the network diagram and information given, create an addressing scheme that utilize variable line subnet mask. Show the subnet address and the CIDR. CIDR means prefix. Prefix. In the boxes below, color or shade the subnet used in the box. This business will be using class C, so you're given the class C address 220.10.10.0. Remember to start with the largest group first, meaning if you want to do subnet, you list out the subnets you need the address for, starting from the largest, descending down to the smallest. So that means you assign the subnet with the largest host requirement first. And then the next largest until the last one. Okay? All right. So you have 60 host requirement. That means find out for 60 hosts how many bits needed. Once you get the number of bits in the host part, okay, you can then deduct from 8, you get the bits you need to borrow of the network part. Right? Okay? Again, I want to remind you, you can use the log base 2. Okay, log base 2 calculator to easily get the number of bits required given the number of hosts. Okay? All right. So another problem here, we now have multiple requirements. Okay? When you see, you start to notice by now, when you see wide area network with 2 required interfaces, it is for class C is normally or class B or class is normally just /30 because that saves the most number of address range because it gives you two usable host addresses. Okay. Then again, simple answer. Right now. After that, for problem 3, you can start to do it yourself. Still using class C, right? Start to do it yourself now. So how do you do this one? So usually, as we say, we want to arrange first. So that means we solve it by solving the others first because largest number of hosts required. Next is the Fort Worth with the second.
This one same as the tutorial we did.
Yeah. Same tutorial. So these are the for you to practice more questions for you to practice on, right? Then the last one is the wide network with the 2 required hosts. Okay, so you solve like this. You sort them out from the largest required host until smallest. Then you submit one by one. Okay, I think the easiest method is using the magic number. Okay, right? You don't need to color, or you can just put what color you want to use. Say it. What's that? Maybe it's yellow, red, okay. I'll answer here. Right, continue with problem 4. Just do a practice, continue. Problem 6, 7, 8, right? Okay, how many you want to do, up to you, okay? As long as you, I think minimum 5 for the class T, okay? What's important is, you need to do more if you're not sure. You're still not sure. If you know, but it doesn't hurt. It doesn't hurt if you want to do extra. Okay. So circle method is basically just use a circle rather than a box, and the division still the same. As you can see, /25 divide into 2, /26 divide into 4. It's just that instead of a box, you have a circle, right? And I think it's very hard for you to draw this kind of the circle type, right? For me, it's a little bit more difficult to draw because it's become very small, right? So here again, if you want to try to do the circle method, you can do, or if you want to use the problem for other methods, magic methods, box methods, up to you. Okay, as long as whichever technique you use, you get you get the correct answer. Okay, this is just alternate methods. There is no set questions asking you to do the submitting of VLSM exactly using a specific method. We don't ask for the working. Okay, you straight away give an answer. So whichever method you feel that is the most comfortable for you to use. Okay, so we proceed examples using the circle method. Okay, and then some further example. Okay, if you want to try out this, but you don't want to use the circle method, it's okay. You can leave the circle coloring without answering, it's okay. Okay, right? So problem solve, continue, again, continue, right? Continue again, circle method. If you want to use the circle method, it's fine. Next is the VLSM chart. No, VLSM chart, right? It's given to you like here. Like I say, it should work basically best for C because you can fit it into a chart that you can visualize easily. Yeah, even this has also become unwieldy. It's already taking one whole page. Okay, sometimes you have to look at it in let me see here. You can see to look at it in one page, it becomes a little bit what already. So imagine if you're doing VSM for class B or class A. There's so many subnets. Okay. Right? All right. So we proceed. It's quite a question will be the problem will still be the same, but now you're using this to refer. Okay, you refer. You just basically just shade the parts that is taken, then you know where you need to start next. Okay, all right. You can see shading the parts you are using. Next one based on the how many bits. Not the important thing here is you can visualize that none of the range, the colored box are the ranges you assign to the subnet. You can notice that the next subnet always starts from the next address range available. Okay, you can see that here. Here, the part here, the part here. It never overlaps, yeah? It never overlaps. So if you are overlapping, something is wrong, you'll make some mistake lah, huh? Never overlaps, yeah? Okay? Right, continue the problems. You can then start to shade. I think doing this will be more intuitive for you as a beginning, right? And then you can continue with exercises, right? Okay. You don't have to do all the exercises, enough so that you can get an understanding that you can do, right? Let's still using chart. We're still on class C. All right. So practical problem. Okay, let me just switch over to this method. All right. So here they give this type of question where you are given basically a scenario. Example here, you are developing a school network with a class C address. So you're given the class C address. Now, sometimes the question do not specifically mention the class name, class C. Okay, they just give you the address. So if they just give you the address, you have to identify what class the address belongs to. So maybe they omit class C and they just give you 192.168.2.0/24. Slash 24 straight away tells you three network portion, one host portion. So that is class C. So straight away you know. So if you don't see the class name given, okay, just look at either the first octet of the address or the prefix. That will tell you what class it is. Right? So these are requirements usually stated. There will be 3 computer labs or 3 subnets with 30 computers each. So each class, each computer lab has 30 host address required.
Oh,
Yeah.
in the exam also need to write one by one all the subnets.
The question normally would inform you either the first four, the last four, but usually it's the first four, okay, depending on the examiner, but they don't, if there are many subnets, they normally do not ask for all the subnets because they, even if they ask for four, if they see that you can fulfill four, they know you can fulfill the rest.
Will they
So
give all the
Hmm?
the tape? Will they give the table
The
for us,
table,
or do we have
yeah,
to do the table ourselves? Like, do we have to create our own table?
yeah, you normally have to create your own table because
Okay.
in the question they will show the table, right? But as I understand from our current lecture group, they prefer the student use PDF. That means handwritten PDF. So that means you have to create your own table, right? So maybe get ready with the ruler or something like that. Okay, so that additional table looks presentable. All right, so where was I at? Okay, does that answer your question, Tristan? Before I proceed, did I answer your question?
Yeah.
Yeah. Okay. Okay. So 30 computers for each of the three computer labs. That's the requirement. And then 48 classroom with one computer each. That will comprise a single subnet. So single subnet, 48 classroom with one computer each, that will comprise single subnet. So that means 48 subnets? Not really, yeah. That means 48 computer in a single subnet. Okay? This word sometimes it's not that obvious. You say 48 classroom with one computer each. So 48 computers, but they're all in single subnet. Yeah. So we're not talking about 48 subnets each with one computer. We're talking 48 classroom with one computer each means 48 computer means 48 addresses needed, but it's comprised of that means it's belong to a single subnet or subnet. Then the admin office and guidance office contain total of 7 computers which we need to be grouped together. So we combine admin and guidance office, and the required cost is 7. Something. Plan for 4 more mini labs, that means for future use. So include this in your design. Plan for 4 more mini labs with 6 computers to each subnetwork. So 4 subnets. Each subnet has 6 computers because it says to each subnet. Right? Then you do the VLSM subnetting. Okay? Here the answer already given to you. Okay? So take the time to do it yourself, and then you can compare your answer with the given answer. If they are correct, then you know you can do it. If not correct, then find out. Because you got the answer already, find out why your answer is incorrect. Okay. So here they give you answers. Here as well, they give you answers and advice. Try to do first, then double check. Right? And then next problem onwards, you have to do it yourself. Okay, hoping that after you do the two, you can now proceed to do it yourself. Right? Okay, problem
So
27, 28. Yeah.
it's over here the subnet start from 1, but before this it start from 0. Why?
Yes. I I think I remember that the Cisco revised it. They start now to number subnet from 1 compared to from 0, right? So whichever we use, I think it's okay. You can start with 0 or 1. but I will try to confirm with our CC because this subject this course is actually run in other branches and main campus also at the same time. So I think I will want to get consensus from everyone, okay, teaching this course. What standards will you subnet 0 or subnet 1? Okay, please remind me later. Then I'll make the answer. Okay, I'll get feedback from our CT and other lecturers first. Okay, so all standardized. If I tell you use subnet 0, then or use subnet 1, and then the rest may individual lecturers may be using different sort. It's not good. So I think I will confer with all of them first. All right. But for now, just follow the workbook. Okay. Follow the workbook. Right. Continue 29. A very good eye. Then you can see that. Right. 30, 31. Again, the more you do, the better you get. Okay. But I understand if you don't have time, then at least do five, something like that. Okay. Can continue this block, right? Problem with detailed map. I'm not sure where's the yeah, here. So here they give you a scenario. Then here you draw, you sketch like you sketch So if you sketch, you take a photo, you can add your image and then paste it here, right? Okay. So the detail map here basically is the topology diagram based on the scenario. Okay. They just want to test your topology diagram knowledge. All right, so let me just get back here. Right. So now we are moving to class A and B. Like I said before, at least minimum 5 for class A for each of the exercises. Sorry, class C. And now minimum 5 for class A, minimum 5 for class B. Right? If you want to do more, of course, here you can see you can. I don't know whether it was not possible to enlarge already. Doesn't matter. We'll use. I suggest. Okay, if you forget, you view back the video in your slides. But I suggest using the magic number method. Okay, it's very systematic. Once you understand how that is used, it's easier to do it faster. For me, I think it's faster. Anyway, here the problems are now based on class A, class B addresses. That means you will be asked to use class A, class B starting network address to do the VLSM. Okay, as this first example. Okay, this is I think class A, 15, right? It's class A, considered as class A. Now the number becomes large. The required number 8 million, 2 million, or this, right? Because class A. Again, please use uh, please use the log base 2 calculator that I've shown you all previously. That is the fastest way for you to find out how many bits. That one you have no problems, then I didn't ask for feedback from you guys for that one. You guys know how to use the log base 2 calculator, yeah?
Yeah.
Yeah, no problem, right? You just simply put in the number of addresses and then take the answer, and then you get the number of bits. If you get the decimal value, that's fine, because that means the number you entered is not exactly at the doubling of the number. So you just round it up. Okay, round it up to the nearest number. Right? So here is that was just example, yeah, showing you the large numbers you have to deal with. Okay, but the technique is still the same. Right, so here's a chart, okay, for class A addresses from 8 to 15 bits, right, because you start going from 8, right, so class 1 is 9, 2 is 10, and so on. And you don't actually stop at 15, you can go on, but it's just showing you from 8 to 15 in this chart, right, right, so that's why I said if you depend on this kind of chart, it can only show you so much unless you have a very large VLSM chart where you continue with slash 16, slash, and so on, right? Becomes unwieldy. Right, so here is the sample problems that when you deal with large number. So 524, 288 plugs up into the long base 2 calculator, right? You can straight away know how many bits required. Minus that from the octet, all the octets are the 3 octets. Then you know how many bits belong to the node portion. Okay, right? So you can see that the answer is already given to this is class B. So that the number of the 16. That means 16. That means you basically need for 524,288 address. You basically need, let me see. You can straight away look at this answer minus, but to do the proper way, you put this 524 to add inside a block base 2 calculator. So if I do that, the value is 524 to add 524 to add. So what I get is 19. So 19, 19, 19, 19, 19, just so customer number 5. Customer number 5 is one. I read out here. I think the customer number 5 is the total is this one actually. It's already given. Sorry about that. Okay. So that means the total address is 524 to 80, right? But each requirement is already given in the table. So you just based on the requirement, to be honest. So client number 1 is 7,500. So you find out 7,500 means 4.8 is 13. So 13 on the horse part. Okay. So 13 on the horse part, you 18 minus 13, you get 5. So 8, 8, 16, oh, 3 actually. Right? 8, 13, sorry, 13, 13, 13. So it's 3. 16 minus 13 is 3. So you borrow 3 bits. You borrow 3 bits means 16, 17, 18, 19. So slash 19 will give you 7,500 number of addresses. Right? Note that it doesn't say usable addresses, so you don't have to I'm not sure. I think in the exam, if you are to avoid confusion, I think mostly now the examiner will put in usable host address. Without the usable, you don't have to minus 2 host address. If they say usable, you minus 2. Okay? Right? In order to find out, you can cover 7,500. So you keep on plugging and minus from 16, you get the cost part. Eventually, you will be able to fill up the entire cider. Okay? And then use the magic number to basically get the range of subnets here. So getting the next subnet, because the cider indicates to you the subnet mask. Finding the last bit borrowed will give you the magic number. Using the magic number, you can then find out the next subnet address, the next subnet address, the next subnet address, the next. Once you get the subnet address, okay, you can then get the previous address as the broadcast address of the previous subnet. So each client here represents subnet, right? That's the using the magic number is easier. The step is find out the prefix, the cider part, right? Once you fill up all the cider part, it's easier for you to find the magic number to add so that you can get the next subnet address, the next subnet address, the next subnet address. Getting the next subnet address and filling up all the subnet address, then will lead you to the broadcast address. Then you can then do the broadcast address, right? Okay, so again, try to work out the next example. Yeah, see whether your calculation give you the same answer. Then you can then try out your own. Okay, your own. Find out the cider. Okay, for example, not high, 2400. 2400, you plug into log-based calculator. That will give you, let's say 2400, give you 11.2, so it's 11 bit. So 11 bit, so slash 11, so the will give you, you always start with the 0, right? And then use the magic number to get the next subnet address and keep on doing that. Once you fill up all the subnet address, if you forget, go back to the VSM slides and play the video where it's talking about for class A and B using magic number. Once you get all the subnet address, you get the broadcast address, okay? Right, and there are more examples, okay? Question, and let's try as many as you can do, but try to do 5 plus A, 5 plus B, okay? Minimum. Can continue, I think still continue to do, if you know how to do all this, okay, you will have no problems doing for either the SBA or the exam, right? And the remaining pages are just reference pages, okay? In fact, for double checking the answer, right? Any question? No, stop my presentation now. Any question for this?
So just now the
Yes, Noel?
the cider is 11 bit, right? Aren't we supposed to round up? Because 11.2 just now. The bit.
Sorry, I didn't catch that. Can you repeat?
Because when I use the log tool, and I put in 2400. So the answer is 11.2, right? 11.2 bit. Aren't we supposed to round up to 12?
No, what I think is for 11.2, it cannot round. It's 11.
Oh, okay.
But you try first. You try first. Because I'm thinking if there's a decimal, means it's not exactly. You can confirm by doing the opposite. Okay, I mean do opposite. Go to the scientific part. Do 2 power 11. If the answer can cover two 400, then no need to round. But if cannot, then you round up to the next one, the closest one, the
Okay.
ceiling. Yeah. So that means I just did it. 2 power 11 give me 2048. It's not enough. So that means it needs to be 12. So 11.2, then choose the next one. You always do, if you're not sure, can always do the reverse the process. Do 2 power of the bits you get. So 2 power 11 is 204x, not enough. So 2 power 12, 2 power 12 gives me, can do yourself on the calculator, gives me 4096. Okay, so the next one is quite big, but it's okay. We need that because the 2 power 11 cannot give us 400. So that means we need to go all the way to 2 power 12. Okay, that will give us 4096, although it's, still far, but that's the next available one. Okay,
Okay.
all right. Any other questions?
So minimum 5 for class A, class B, and class C, right?
Yeah, minimum but minimum.
Okay. That's a problem.
What about Kelvin? Kelvin, okay?
Oh yeah.
Oh, yeah. So, Farron,
Okay.
it's okay. Then I leave you guys to do. Okay, I'm monitoring your uh, this chat, this meet. So, any question, just let me know.
Okay.
Okay. Thanks. You guys okay? Any issue?
So far, no.
Okay. Okay, noted. Well, so class A, so you went straight to class A, is it? Or you did class C also first?
What?
No, I can't. Let me just raise up the volume first, yeah? Yeah, no, what did you
Was it?
say? Okay. Alright, so we've done class A, class C. Well done, huh? Class A. Class A is the, if you know how to do class A, I think class B should be no problem. Yeah. The rest, okay. Okay, also, hopefully you also have some progress.
Yeah.
Yes, Calvin?
Uh,
You're doing class C or class
uh, I'm still doing the workbook for the IPs and subnetting.
Oh, okay, okay. Alright, that one is also important. Because the one, if you, that one is the prerequisite lah. We will say that that's a prerequisite to doing VLSM. Okay, you cannot skip. If you get better in subnetting, the normal subnetting, then you will find that you have less problems with the VLSM.
Yeah.
Cannot skip the subnetting. Yeah.
Do I have to submit all the answers? Or
No.
do I
No.
just practice on there?
Sorry.
All these projects, or just practice on it, no need to submit.
Um, no, you can submit also. I will open up a classroom submission. Okay. But actually, the main purpose is for practice.
Yeah.
Yeah. But for my record, maybe because since you guys done it already, then I will open up in the classroom for you to submit. Okay. Later on, lah.
Oh,
But the main purpose is for exercise to get you guys good at the Zoom. Yeah.
yeah. All these keep repeating the same, no, keep repeating the same formulas.
Yes, yes, this is very important. This one is very important, and it comes out both in SBA and in the final online assessment. So all these exercises doing it to make sure that students know how to do. Because previously students tend to have problems with this, and then they can't do it in SBA. It affects their coursework, and they can't do it in the exam, and it affects their exam. So yeah, as much as possible, I would like all of you know how to do it. Make sure you guys know how to do it before the SBA revision. Also do the SBA itself. So if you know how to do it in SBA, definitely you will have no problems in the exam and the exam. How about you, Farah?
He went to toilet.
Okay. All right. Okay, so guys, thank you for today. I think I have to get ready to go for my meeting, online meeting already. All right. Okay, have a good weekend. I'll see you guys next week. Yeah.
No, no. Thank you,
All
sir.
right. Thank you, Noel, Kelvin, and Farah.